All right, so this is the last section we're going to do in chapter 5 with our rational root and power functions. We're going to do 5.3, looking at inequalities, models, and applications. So inequalities and word problems is really what we're working with here. All right. So solving rational equations or an inequality, it's just like solving an equation with one term having a variable. So if you have an equation or an inequality, you're going to solve them the same way. You just end up dealing with your final answer as a solution or an interval. So if we wanted to solve this, the first thing we want to do is note if anything makes it undefined, because in the end that could give us an extra answer. So to be undefined, we set the denominator equal to 0 and solve. So in this case, x cannot equal negative 1/2. So we want to keep that in mind. Now we need to solve this. So when you have one that's a rational like this that just equals a constant, you can multiply by the denominator to move that whole thing to the other side. So if we do that, it cancels here, and we're left with x plus 2 equals 1 times the denominator. So really that's 2x plus 1. If we subtract x from both sides, we get 2 equals x plus 1. Subtract 1 from both sides, we get 1 equals x. Now, if I look at my answer, 1 equals x, and over here on our undefined, it can't equal negative 1/2. Well, that's not the answer, so we're all set. So our solution set is x equals 1. Another way to do it is to subtract that 1 from both sides and set it equal to 0. Then put this in our graphing calculator. If we put that in our calculator, then we just find the x-intercept, and that gives us our x value. So that gives us the same answer whether we graph it or not. A third option is to graph in y1 our x plus 2 divided by 2x plus 1. In y2, graph the one that it equals, and then look for that intersection point. And remember, on the graphing calculators, you hit second, trace. For the x-intercept, you hit 0. And when you have the two things intersecting, you hit intersect. So that's how you would do that on the graphing calculator. Now, sometimes you have a more complicated rational equation, so you can't just multiply by both sides by the denominator. So here, we are going to still start by writing our inequalities, the undefined. So we're going to make both of these x minus 2 equals 0. So if I add 2 to both sides, x cannot equal 2. So that takes care of this one. X plus 2 equals 0. Subtract 2 from both sides. X cannot equal negative 2. So those are our restrictions. X squared minus 4 is a difference of squares. So if we were to write this out, it would be x plus 2 times x minus 2, which gives us the same numbers for the undefined. So that's how we start. Now we need a common denominator before we can add these together. The right-hand side has a common denominator, or has a denominator of x plus 1 times x minus 2. So that's what we'll use. So we need to multiply this first fraction by x plus 2, because that's what the bottom is missing. And we need to multiply the second fraction by x minus 2, because that's what the denominator is missing. So to do that, on the top, we're going to distribute the x. So we get x squared plus 2x over x plus 2, x minus 2. And then here we distribute the 1. So we get x minus 2 over x plus 2, x minus 2. And that's going to equal 8 because we don't have to multiply anything because it already had the common denominator. Now, where all the denominators are the same, we can ignore them while we're solving. So we can just bring our numerators together, combine like terms, and solve. So we would combine the x's. And to solve a quadratic, we need to subtract 8 from both sides. So -2 minus 8 is -10. Then we could tic-tac-toe this. So we have 1, 3, -10. So our choices are 2 and 5. So we'd want a -2 and a +5 to get our 3. Common denominator, greatest common factor, multiply across. We get x minus 2 and x plus 5. So now we solve it just like a regular quadratic. Make each of these equal 0. X plus 5 equals 0. So we get x equals -5. Those are our two solutions. But if you remember up here, x can't equal 2 because it would make it undefined. So the only solution that works is -5. So x equals 2 would be extraneous. It's not going to be part of the graph. So we just have that one answer. So that's what we just talked about. Graphing calculator, if we subtracted the solution from both sides to make it equal 0, we could just type this in, remembering to put your denominators in parentheses when you type it in, and then find your y-intercept with your second trace 0. We would get -5. And if you look over here where x is 2, there's a hole in the graph. So it shows that that's another way to see that it's not the solution. So solving rational equations. You want to figure out where it's undefined. Then clear your fractions by getting your common denominator or making everything the same so you can ignore them. Solve it, and then reject anything that made it undefined. So that's what we just did. So let's try an inequality. We're going to do the same thing. So if the notes on here have it subtracting 1 from both sides to make it equal 0, finding a common denominator, and then combining like terms on the top. So x minus 2x would be -x. And 2 minus 1 is 1. And we know that needs to be less than or equal to 0. So if we subtract 1 from both sides, we get -x is less than or equal to -1. Divide both sides by -1, which flips our inequality. We get x is greater than or equal to 1. We know x cannot be -1/2. This is the same as the first problem we did. If we chose to do it the other way, where we just multiplied both sides by 2x plus 1, we would get x plus 2 is less than or equal to 2x plus 1. Subtract x from both sides. 2 is less than or equal to x plus 1. Subtract 1. 1 is less than or equal to x. We get the same answer. These are both the same. So our parentheses would be -infinity to 1. X is greater than 1. Nope, I lied. It'd be 1 to infinity. Read your problem right. So it'd be 1 to infinity. But it can't equal -1/2. So if we get down here, this is the rest of that one out that I just did. It can't equal -1/2. So we have to make intervals. Remember, whenever we're doing inequalities, we throw intervals in there. So we have -infinity to -1/2. Because that was where we know there's a hole. We know the solution goes from 1 to infinity. But we need to check all 3 pieces just to make sure. So here I would check -1. Here I would check 0. Here I would check 2. So if you plug those into our original equation, so we're going to go back here. Remember, with inequalities, you always want to check your intervals just to see if that's the only piece or if there's more. So x plus 2, 2x plus 1. So x plus 2, 2x plus 1. And it was less than or equal to 1. So I'm going to plug -1 in. So let's see. X plus 2 divided by 2x plus 1. If I plug -1 into that equation, I get -1. So -1 is less than 1. That works. If I plug 0 in, I get 2. 2 is not less than 1, so that doesn't work. And if I plug 2 in, I get 0.8, which is less than 1, so that works. So even though analytically we got the 1 to infinity, we can tell with this that we would also have -infinity to -1/2 as something that works. So you want to make sure that you're checking both pieces. Because remember, with your rational functions, you have two pieces like this. So we need to know which parts of both pieces work. That's why you want to still check or use your graph and see that way. So we just talked about that. If we used our graph and we graphed this equation, we would see that right here, it breaks. So we have this piece. That was the original one we found. But we also have this entire piece that's before that vertical asymptote. So you always want to check all your pieces. So inequalities, same thing, test your intervals. So x squared over x minus 2. X squared over x minus 2 is less than or equal to 0. So first we figure out what makes it undefined. Well, x cannot equal 2. We've got that. So now we solve. Multiply both sides. X squared has to be less than or equal to 0, which means x is less than or equal to 0 because the square root of 0 is 0. So if we make our intervals, again, we can treat it like an equation. Ignore the equals part, or the less than part, actually. Treat it like an equation. X equals 0. So we have -infinity to 0 as one interval. We have 0 to 2 as another interval. And we have 2 to infinity as a third interval. So here I would check -1, 1, and 3. So if we plug -1 into x squared divided by x minus 2, we get -0.3. That is less than 0, so this one works. Plug 1 in. We get -1. That also works. Let's see, 1 squared, 1 minus, yep. And then if we plug 3 in, we get 9, so that doesn't work. So we got yeses on these two, which means our solution is those two connected. The 2 is a bracket because it's less than or equal to. But it's not a bracket because it can't equal to. So it's just parentheses. And then I'm going to try plugging in 0 and see what happens. 0 stores x. We get 0. So in this case, because it can equal 0, it would just be -infinity to 2. Because it can equal 0. If it hadn't had that equal sign, we would have to have the break. So that less than or equal to makes it one range. So there are the intervals we just tested. All right. So here, we're going to start this one. We want to write it so that 0 is on one side. They like 0. So we're going to subtract 2 from both sides. And we get 1 over x minus 1 over x minus 2 minus 2 is greater than 0. Now we want our common denominator. So this doesn't have one, so it needs an x and an x minus 2. So we multiply the top by x and x minus 2. The middle fraction is just missing an x, and the first fraction is missing the x minus 2. So really, I just took all the denominators and multiplied all the pieces by what was missing. So here we distribute, and we get x minus 2. Here we distribute, so we get minus x. Here, first I'm going to multiply these two together. So I would get x squared minus 2x. Then I distribute the negative 2 to that. So negative 2 times x squared is negative 2x squared. And negative 2 times negative 2x is 4x. And we can ignore the bottom because they're all the same now. So now we solve this. So if I combine like terms, we have a negative 2x squared. And then we have an x and a negative x, which cancel. So plus 4x. And then minus 2 equals 0. So let's see here. How did I do that? If I tic-tac-toe this, we get negative 2, 4, and 4. So factors would be 2 and 2. Greatest common factor would be 2. Multiply up. Multiply across. So we get negative x plus 1 and 2x plus 2 equals 0. So if we solve these, negative x plus 1 equals 0. We get x equals 1 as a choice. And then 2x plus 2 equals 0. Divide by 2. X equals negative 1 as a choice. Go back to the beginning. X can't be 0 because of this fraction. And x can't be 2 because of this fraction. So now we have our intervals. So our numbers, we have a negative 1, a 0, a 1, and a 2. Those are the numbers, our solutions, and our undefined. So we would go negative infinity to negative 1, negative 1 to 0, 0 to 1, 1 to 2, and 2 to infinity. So now we have to test all these pieces. Yep, all right. So we're going to test negative 2, negative 0.5, positive 0.5, 1.5, and 3. So if I type my equation in there, so we have 1 divided by x minus 1 over x minus 2. And we want those to be greater than 2. So if I plug negative 2 in, I get negative 0.25. That is not greater than 2. So that's a no. Test negative 0.5. I get negative 1.6. That is also not greater than 2. If I test 0.5, I get 2.67. That is greater. So we know that's part of our answer. Test 1.5, and I'm just testing them by plugging it in that original equation. So 2.67. So that's true. Then I'm going to test 3. And I get negative 0.67, so that is not true. So we need to check 1, because 1 is in both of those intervals. So if I check 1, I get 2. This is not equal to, it's only greater than. So we would have to write those parentheses without a connection. So that is the interval where that equation is greater than 2. So we're solving them the same way as the equations. We just have intervals to test whenever we're dealing with inequalities. So that's exactly what we just did. All right, so solve this. Now we're looking at things that seem similar, but they're a little bit different. So now we have negative exponents. So a negative exponent makes everything move to the bottom. So to do this, we're going to solve the equation, f of x equals 0. So our negative exponent moves that to the bottom of a fraction. So this is really what our function looks like, and we want to set it equal to 0. So we rewrote this so that it was equal to 0, which is just moving our negative exponents down. So now we need a common denominator. Well, 4, 2, and nothing, we're going to make x to the 4th our common denominator. So this one needs an x to the 4th on the top and the bottom. The middle one already has 2, so we just need 2 more, and then the 7 stays the way it is. So now we can rewrite this. X to the 4th minus 8x squared plus 7 equals 0. It's all over x to the 4th, but again, when we equal 0, we can cancel that out. So now we can solve this one. So we're going to tic-tac-toe, but keep in mind that we have a 4 here. So 1, -8, 7. So to get a negative, we'd have to have -7 and -1. Greatest common factor, multiply up, multiply across. Now, because of this 4, these are really x squared minus 7 and x squared minus 1. And we want to solve these. So we make them both equal to 0. Bring the 7 over. We get x squared equals 7. Take the square root. We have x equals plus or minus root 7. Then we do this one. X squared minus 1 equals 0. Bring the 1 over. So this is going to equal plus or minus 1. So we have 4 solutions now. The only thing that can't go on the bottom is 0. So those are our answers. Now we're going to graph the equation and identify the zeros. So we solved it that way. If we graphed it, if we put the original equation in there, we'd have this graph, and we would find these same x-intercepts. This is just the square root of 7, not exact. So we got plus or minus root 7 and plus or minus 1 analytically. And graphically, we got the same thing. They show us those in this table. Now, if we're trying to solve for, what was the last thing? Less than and greater than. So, if I want to know when this is less than or equal to 0, we have these pieces right here. So it's 2 pieces, which means we need 2 parentheses. This one goes from negative root 7 to negative 1. And this one goes from 1 to root 7. And they were less than or equal to, so these would be brackets with a U in between. If we were doing greater than, we have 4 pieces, so we need 4 parentheses. So negative infinity to negative root 7 is this first piece. This piece is going to be 1 to 0, because 0 was our asymptote. This piece would be 0 to 1, and this last piece would be root 7 to infinity. Now we have the parentheses at 0 because that's our asymptote. It can't actually equal 0. All right, let's see here. Okay, here's a word problem. Modeling traffic intensity. Vehicles arrive randomly at a parking ramp at an average rate of 2.6 vehicles per minute, and they can admit 3.2 cars per minute, but arrivals are random, so things are variable. So the intensity is the arrival divided by the admittance. So to do that, they divided those two and got 0.812. That's where that comes from. So now we're going to get this equation here. This equation is the vehicle line. And we want to know the average number of vehicles. So we're going to use that number we just found by dividing, which gives us 1.76 vehicles. So on average, there's almost 2 vehicles waiting. So this was the equation, and then we use that average from before to solve it. If we graph that equation, what happens as the intensity approaches 1? So the more intense it gets, the more cars are waiting. So this is our intensity. This is the number of cars. So the more intense the arrivals, the more cars are waiting. That makes sense. All right, so solve f of x equals 24 and interpret the results. So we're plugging in 24 for y. So to solve this, we're going to multiply both sides by the denominator. So 24 times 2 is 48. And 48 times 1 minus x is 48 minus 48x. And that equals x squared, because we canceled this. So I'm going to move these over. You can go either way. It doesn't matter if you go to the right or the left, but I prefer to keep the x squared positive. Just makes life a little easier for myself. So I get 0 equals x squared plus 48x minus 48. If we do the quadratic formula, so negative b plus or minus b squared minus 4ac all over 2a. If we do that math out, we get minus 4 times 1 times negative 48. We get 0.98 and negative 48.98. Well, you can't have negative cars, so when there's 24 cars waiting, the intensity is going to be 0.98 or almost 1. That's how you interpret that. Reject, we just talked about that. All right, here's another problem. We're getting there. Manufacturer wants to construct a cylinder with volume 2,000 cubic centimeters. What radius and height will minimize, so we know we're looking for a minimum, the amount of aluminum used. So if we have our thing, we know x is the radius and height is our h. So volume of a cylinder is pi r squared h, so there's our volume. We want the volume to be 2,000, so plug that in for v. And then we solve for h, because we're trying to minimize one of them. And x is squared, so it's easier to solve for h. So we use that. So we took the formula for volume, plugged in our radius and our height, plugged in the volume we wanted, and then solved for h. So we divided by pi x squared is what we did. Now we want to minimize the amount of aluminum, which is the surface area. So the formula for surface area is 2 pi r h plus 2 pi r squared. Well, we put the x in, and we just solve for h. We just said on the slide before that h is 2,000 times pi x squared. So if we plug that in for h, Now we only have one variable. So we can do some math out here. So 2 times 2,000 is 4,000. And if we have a pi on the top and a pi on the bottom, they cancel. And if we have an x on the top and an x on the bottom, there's really just one x left on the bottom. And then we're going to add this to 2 pi x squared. So now we solve. Well, we want a common denominator. So if we multiply this by x, this becomes cubed. So that's going to equal our surface area. So we can plug that in the calculator. 4,000 divided by x plus 2 pi r cubed divided by x. Or you can combine them. But you plug it in. And then you do your second trace minimum. And it gives you this as our minimum x value. So that's our radius. And that would be the minimum surface area. So this is why we spent so much time solving for variables, because it's going to help you solve problems later. Okay, inverse variation. So way back somewhere in your mathematical career, you might have learned inverse variation. So when things are inverse, they're going to vary with division. K is a constant, so y is just going to equal that constant over x to whatever power they're telling you. Direct variation, so this is inverse. Direct variation is the same thing, except it's multiplying. And then we'll get there. Okay, so for modeling intensity of light. Intensity of light is inversely proportional. So that automatically tells us it's k over something. Then it says the second power of distance. So that's where the d squared comes from. So that sentence is what we use to write this equation. Then it gives us some information. At a distance of 3 meters, a 100-watt bulb produces an intensity of 0.88. Find the constant K. So we're going to plug them in. Intensity is 0.88. We don't know K, and we know the diameter is 3. So 3 squared is 9. Multiply both sides by 9, and we get K equals 7.92. Now we want to find the intensity when the distance is 2. So we're looking for I. We just found K. And our distance is 2. So now we're going to do 7.92 divided by 2 squared, which gives us 1.98. So the intensity 2 meters away is 1.98. Sorry, I keep scrolling. I'm just making sure it's recording. So here's the math out a little more neatly if you want to check that out. Joint variation just means they all go together. So you multiply everything. You could have joint inverse and direct. We'll talk about those, but that's really what this is saying. It's just combining all of those things. So volume V of wood varies jointly. So we're doing multiple things. With 1.2 power of height. So volume jointly, height is 1.12. And the 1.98 power of diameter. So D times 1.98. So this is our equation just by that sentence. Now they tell us the diameter is measured 4.5 feet above the ground. So write an equation. We did that right there. Then they give us a diameter, a height, and a volume. So they want us to solve for K. So we would do 25.14 equals K times the height, so 64 to the 1.12, and the diameter is 13.8 to the 1.98. Did I leave? Okay. let's do this. There, give me some more room to write here. I know it's crooked, sorry. I can't, yep. So if I put that in the calculator, I get 25.14 equals K times 19049.43775. We're going to divide both sides by this, and we get K equals 0.00132. Now, we want to estimate the volume when we're given a diameter and a height. So volume equals, but instead of K, we're going to put 0.00132. H is 47, and that's to the 1.12 power. D is 11, and that's to the 1.98. So if you type that in your calculator, remember the caret is how you get exponents. We would end up with a volume of 1.36. So diameter, volume, cubic feet. Because that's what they did the volume here in. So 11.36 cubic feet is how we do that. Here is the work done out a little more neatly in case you want to see it, and a picture. And then how we solved the next part once we knew K. The strength of a rectangular beam varies directly with width, so kW, and the square of its thickness, so we're still direct, so thickness squared, and inversely with its length. So now we have a division problem. So that's how you put them all together. You just go by directly what it says. A beam is 4 inches wide, so W equals 4. 10 inches thick, 120 inches long, and can support a load of 1,250 pounds. Determine a similar beam with this information. So first we have to find K. So if I do 1,250 equals K times 4 times 10 squared over 120. Well, we multiply both sides by 120, and I get 150,000. And if I do 10 squared, that's 100 times 4, so it's going to equal 400K. Divide both sides by 400, and we get 375 equals K. So now we know K. So our equation is S equals 375 W T squared divided by L. Using this equation, it's 3 inches wide. So we're going to rewrite that with a 3 here. 12 inches thick, so 12 squared, and 100 inches long, so that goes on the bottom. If you plug that into the calculator, you get 1620 pounds is what it can support. So you're just playing with equations to solve for X. All right, the last part of this. Oh, here, hold on. So that's the solution. They broke out different ways. They reduced first right here instead of multiplying. It's just another way to solve the same problem. All right, rate of work. So if you're starting to talk about someone can complete this task in this many hours, you're going to write it as 1 over X. So if Martha can complete a task in 4 hours, her rate of work would be 1 over 4. That's what this is showing us. So it takes machine B 1 hour less to complete a task working alone than it takes machine A. So machine A takes something, and B would take 1 hour less than that. So those would be their rates of work. If they start together, they can complete the task in 72 minutes. Well, our rates are in hours, so we need to turn 72 into an hour. So we divide by 60 and get 6/5. That's where some of these numbers are coming from. So 1 over x is the rate for machine A. 1 over x minus 1 is the rate for B. And then to do the rate together, we do 1 over 6/5, which flips the fraction and makes it to 5/6. That's where those come from. Now, if we put our two rates together, so machine A plus machine B gives us the total rate. That's where these three fractions come from. So now we solve. Use what we talked about to practice this and then come check. So this one needs x minus 1 to have a common denominator. This one needs x. And this one needs both. And because this has a 6, these also need a 6. Because we want all the denominators to be in all of them. So now let's multiply. 6 times 1 is 6. And then if we distribute that to x, we get 6x. And 6 distributed to -1 is -6. Here, 1 times x times 6 is 6x. Here, so that's going to equal 5 times x is 5x, times x is x squared. And 5x times -1 is -5x. All of our bottoms would have the same denominator, so we can ignore it for the purposes of solving, other than what it can't equal. So if we look here, x cannot equal 0, and x cannot equal 1. So those are those things. So now that we've done that, we can ignore the bottom and solve. So if we, let's see, 6x plus 6x is 12x. So if I subtract 12x from both sides, I have -6 equals 5x squared minus 17x. We want to add 6 to both sides. So 0 equals 5x squared minus 17x plus 6. Now we're going to tic-tac-toe. So we have A, B, and A times C. To get 30, we'd need 15 and 2. So if they're both negative, it makes 30 positive. Add them together, we get -17. Greatest common factor. Multiply up. Multiply across. We have 5x minus 2 and x minus 3, which solved out gives us 2/5 or 3. Neither of those equal 1, so we're good. So now, the one thing we want to pay attention to is if A were to take 2/5, B takes an hour less than that. So if we subtracted 1, we'd get a negative number. Well, you can't negative work, so this one doesn't work. So A has to take 3, and B would take 1 less than that, which is 3 minus 1 is 2. So this explains that again. So that is 5.3. I will do a quiz walkthrough one day this week without talking again, but I wanted to make sure this got out there. Let me know if you have any questions.